Hallo, mein Name ist Rashid, ich bin einer der Messeveranstalter vom ITCS und im Rahmen des Programms laden wir immer unseren Kooperationspartner, das AI Meetup Frankfurt, ein. Hier werden wir jetzt in den nächsten 2 Stunden 3 tolle Speaker willkommen heißen, ich glaube auch über Zoom. Und ich gebe jetzt einfach mal das Mikrofon an den lieben Danko. Und lieber Danko, schön, dass ihr da seid. Und lieber Frank, natürlich du auch. The stage is yours.
Okay. Yeah. Hi. So, hello everybody. So, it's really great to be a guest at ITCS. This is our, I think, 3rd time we are doing it with ITCS. Usually, always December. So it's kind of became a tradition that AI Meetup comes to this fair. This is really cool. Today we will have 3 different talks. Maybe we want to see the schedule. So Bernd Vordermann will talk about data mesh. So the first talk will be about data. Data are very important for AI. And then after that, we will have 2 talks about Gen AI. This is today the hot topic, but all of the hot topics start from data. So the first talk will tell us how a company can better organize data. So why is it important? Because it's not so easy to organize data. We all know that it is important to have data. It is important for a company to keep their data, to organize the data, but it's not so easy. And if we look historically, the way how companies organize data has changed, and the philosophies has changed. They all started initially with just standard databases, right? But then that wasn't good enough. So people came up with all kinds of different things, right? And now data mesh is, I think, the newest and the best way so far we have developed. And I think we will hear from our speaker about that. Do you want to come here? Or do you want to be in the corner? What do you prefer? All right, so maybe you can just switch. So a warm welcome to our first speaker.
Hi, everybody. Okay. Maybe before we start, a quick show of hands. Who has already a career in data or AI at the moment? Okay, a lot of people. And of those who don't have yet a job in AI or data, who thinks in the next, I don't know, 20 years, 10 years, it will be relevant for their job and their career to know about data and to know about AI? So everyone, right? Okay. So this is what this talk is all about. How can organizations deal with it? Short announcement about me. So I'm Bernd. I'm for 22 years a freelancer here in Frankfurt in different projects, also data projects, AI projects. As they come about, I consult regarding data-driven strategies to enterprises and also do AI consultation in the field of AI regulation, which is about to become more important. But I will not talk about this time. This time, I'd like to bring to you the key message of this talk, which is with data mesh, which I explain shortly, every organization can establish and also scale data-driven best practices, including, of course, machine learning and AI. So who thinks these are just a lot of buzzwords? Okay, one honest person. So when we look at the data-driven enterprise, so this is an organization, company, which is building its processes and its decisions on data. There are a lot of important stuff that you need to deal with all the time, all the day. For example, if you're a data engineer, you deal a lot with data preparation from the top row, data science, ETL processes, so preparing data, changing data, visualizing data, and so on. And a lot of companies already adopted this kind of practices, but it's important to be really successful in this field and with these practices to consider 4 major pillars. The first pillar is not to deal with the data alone, so data as a self-service, but consider domain-specific use cases with the data and look at your business, what you want to do with it. I talk about this a little bit later. Then make data practitioners collaborate. So a data scientist should not work on his own the whole day, but he needs to collaborate with others from the business, from data, from technology in a team setup. So this is important to enable this. What's also important is to get the data out of the systems where they are currently and give them to the people who want to deal with them, who want to build something with them. And first pillar is that you integrate tools, technical tooling into your everyday workflow, make them available for everyone without much hassle. So these are the pillars, and this is the foundation for success when dealing with data from a very high level perspective. So now we come to data mesh and how this is relevant to this topic. So data mesh, very shortly in a nutshell, I go into the details also. So data mesh has been created as a concept. It's not a product. It's not a technology. It's more like a concept for scaling data-driven capabilities. So if you are a small startup, for example, you are 3 people, 4 people, 5 people, data mesh is not the right thing to do. But if you are an organization which started to deal with data-driven approaches, and you want to scale out, then you need to look at data mesh. Because data mesh tries to overcome some of the shortcomings, some technical approaches present to you. For example, if you know maybe somebody who is familiar with data, they know data warehouse, data lake. So these approaches, they come to a certain point, but then they don't scale anymore. And the data mesh tries to have a holistic view in relation also to these 4 pillars that I showed in the previous slide. For example, deliver business value, which is always important for a company. Make data sharing possible, make it effective and also practical so that you, as a data practitioner, like to deal with data and are easy. It's easy for you to get some resolution. And for companies, of course, for example, if you're in the financial industry, health industry, but also in other industries, it's important to have governance so that there is a view from the company point of view what is done with the data. So this is governance, standards, and control. We can't not live without it, unfortunately. And when we have a closer look at data mesh, then we can look at this diagram. I think it's from the original book from Chamath Dehghani, who invented the data mesh concept. So in the center, there is the data mesh shown as a diagram. And you have these 4 pillars that are shown on the left. You have some kind of pillar on top of it, which is the federated computational governance. Then you have at the bottom, you have a platform which delivers all the technical tools you need to do what you want, which is self-service. And in the middle, there are teams. There are in the circles, different teams from different domains. For example, one domain could be from sales, One domain could be manufacturing. One domain could be product, whatever your domain, the domains the company has. And every domain, every department, every team is responsible to deliver data products. So this is one of the very central concepts of data mesh. And you can see, here it's not presented, so you can see that there are teams which create data products, and these data products can then be shared to other domains in the company, in the enterprise. Okay, so you see there are three main layers. One is about organization, about process at the top. One is about technology at the bottom, and in the center there are data products. So what is data as a product or data products? So just to clarify, I will use the term data as a product and data product interchangeably in this talk. But in general, data as a product is about the general concept from the book, and what is created following this approach, the data as a product approach, are a lot of data products, hopefully in a data mesh organization. So now we want to apply this a little bit more to artificial intelligence, AI. So if you have an AI model like this, and you have the creator, the AI expert who created the model, of course, he knows everything about the model, he's an expert. And if she wants to give the model to some other expert, of course, the expert knows what to do with it, right? It's pretty easy because he's in the domain of AI. But what about if there's some other user, right, who doesn't know anything about AI, just wants to use this model? This doesn't work by just looking at the model itself, right? So if, for example, OpenAI would give you their model, you could do nothing with it, right? You need to have a front end, some prompt where you can type in your request, and then there's a lot of components which are running, and finally the model which will give you the answer. So this is not a product. Yeah, your AI model is not the product. But what is a product? So a product is composed of three important things. The first one is the user. You need to understand what your user needs to do and what product he wants you to deliver. Then there's the business. The business needs to think about, okay, what is my product? How do I sell it? What will it cost? Do I have the skills to develop it? What do we do for marketing and so on? So this is also part of the product. And then there's, of course, data and technology, which also is relevant for the product, but do not forget the other two important aspects. And there's a concept when you want to approach a product. For example, you want to build an AI product, you can apply the product thinking concept. And for the product thinking concept, and you cannot see this probably, it's shaded here that only the user and the business is relevant for product thinking. So you can completely exclude the technology and the data for product thinking. And this is important because often when people start to build a product, they first think about the technology, about the cool AI models they will be creating, the cool data they have lying around. But at first, you need to think about the user and how you want to bring this product to the user. So when we talk about data products, there are two terms in it, product and data. I talked about product already. Now I will talk a little bit about data. How is data relevant to build a product? And I don't know if you've seen that, but there's a pyramid. I didn't come up with it. Some scientists came up with it, that there is a way to leverage data above just the pure data, right? At the bottom you have the data, you store it somewhere, and so on. You have it available, but data, you cannot really do anything with it. You have to transform data and you have to leverage the potential of the data by, for example, cleaning it, aggregating it, merging it with other data and so on. And this way you create information and also knowledge. And at the end, you create some insights in the data. And this is at the top of the pyramid. And when you consider the product approach, then it's relevant to look at the final stage, what you made of the data. This will be part of your product. So the term data product maybe is not so good, should better be information product or knowledge product, insight product, whatever. So this is where you make your user happy. And these are some characteristics that the data mesh proposes, some capabilities that your product must have. At first, of course, there is at the top security. This is always important for every IT product. You need to have it. But in your company, think about somebody builds a great data product, but the others cannot see it. They cannot discover it. They cannot look for it. So it needs to be discoverable. When they have discovered it, they also need to be able to access it. So it needs to be accessible. They need to be able to understand it. They need to trust the product. And it should be available in a way they want to consume it. Yeah? So not some raw data. If they want to have it as JSON file, you put out JSON. If they want to have another format, you need to accommodate to your users. In the end, it also needs to be interoperable, because just using one product will create the need for more products and more products. And in the end, it needs to be valuable on its own, of course. It needs to have a business value, like we said in the beginning. So, machine learning as a product. This is how many companies do it. They have a product team, and they have a product already. Some customer using it, for example, using an API. And then there's some data coming out of this product, which is then just dumped from this product and just handed over to another team. And when they do that, you lose all the context, all the knowledge about the product. So those data-driven teams, they often struggle to really make use of this data and make something out of it. So this is not the best approach. What can we do instead? We can create one team, which is a domain-centric product team, which also creates not only the core product, but also the data product in the same kind of domain and the same team. And this has a lot of advantages. For example, in the AI case, there's a team building the product, and it will also deal with how to create the AI model. This is a much better approach, which is probably much more successful. So how does a team like that look like? You have a team like ML engineers, data scientists, and so on. And then you have a product owner. Maybe you, in the agile approach, you know that there could be or should be a product owner responsible for the product. And you have a backlog, and you talk to your consumers, and you learn from them, and you build the backlog according to their needs. And then you build the product. So this is the right approach. And then, of course, you build the infrastructure, how this model, this AI model, is used, as we said earlier. So there's maybe it's an API or some website, something else that the user really wants to use or likes to use. And when you do that, you get all these capabilities and properties of the data product from this approach, from this process. Your backlog that you build together with the consumer builds a trust in the product, that you build the right thing. But all the other components of the data as a product approach, they come when you really build a product out of it. If you now think about, how should I anticipate what my users want? There are a lot of approaches to do that, but one very promising approach is the value proposition canvas. You can print it out, hang it on a wall, put your stickers on it, and just answer a few simple questions. What does a customer need to do? What's his job? What are his pains? What are the gains from the product? And then derive the product from that. But now we are talking about data product, not products in general. So there are dedicated approaches, canvases that you can use to build data products. And there's one here as an example. You can go through it. It's a simple approach. You can do that in your team, led by the data product owner. And finally, you have all the important aspects that you need to consider when building an AI or data product covered. So now you have kind of the requirements and an idea what your product would be after you build it. And then you also need to build some important components on the way. Of course, you need the data, right? At some point, you need to have the data, actually. You look for data sources and you store them with you. Then you try to work with the data. For example, one important aspect is creating features out of this data. For example, if you have, I don't know, some image model that recognizes all the animals on the image, you would have a lot of features that represent these kinds of animals, right? You want to have recognized dogs, cats, and so on. So these are the features. And you need a specific store for that. Then you create your model, of course. And in the end, you create what's called an inference system where you actually interact with the model. So your customers, your users can use it. And then to have a complete product, to have the complete insight what the product does, you also have an evaluation store where you store every interaction that your users are doing with the product. For example, if you type something into ChatGPT, of course, OpenAPI keeps what you typed and what came out of it to improve the product in the next iteration. And then, as a company, of course, you also have architectural diagrams, right? And when you look at some reference architecture I display here for such a product, an AI or machine learning product, it looks quite complicated. So in the center, we have the AI model, but there are a lot of components around that. A lot of storage, a lot of different things you need to take care of. For example, if you allow your users on the internet to upload something to your model, maybe some image, of course you need to check the image, right? If there's nothing malicious on it or something you don't want to have in your system. So you need some kind of filter. And there are many more components here to this architecture that are relevant. And if we now map this architecture and look where the data mesh and data as a product is capabilities come in, you see that in the center where the most interesting thing for an AI practitioner is the model, there's no relevance to the actual product, right? To make it a product. Of course, you need to have the model, but all these aspects are somewhere else in the architecture. So this emphasizes that you cannot only build an AI model, you have to build much more around it to actually make it a product. So now we took a deep dive into data as a product. Now we're coming back to the data mesh. Let's now see how this approach can support teams in building a lot of data products. So we again map here some of these capabilities that your products should have. And you see that they are not as in the center at the products themselves anymore. If you use this scaling approach, data mesh, these properties will be delivered by others for you if you are one of the teams building a product. So you have less to do and gain some of the features of building data products from the self-service platform and from the governments. And this is where you see that this approach can help companies scale building those products. So in a summary, what should you do when you want to go this route? Establish product thinking, use some canvas to understand what your customer really wants, focus on the actual use, not on the technology and on the data in the first place, then create a backlog by talking to your users. Of course, build a great team, build all the capabilities, and consider all the non-AI aspects also that are relevant for the data as a product approach. Build a solid system, solid architecture, utilize the organization's asset if you have a data mesh, if you have a self-service platform, if you have governance already in your organization, and use those capabilities and assets. And in the end, if you own and run the system that's behind the AI product, then you will also gain insights how your customers, if your customers succeed with it, what they still need from it in the future, and you can iterate and start from the beginning. So this is what I try to deliver here. With Data Mesh, every organization can establish and scale data-driven best practices, including machine learning and AI. I hope I could convince you that this is the case. So I'm consultant in the field of AI regulation. If you need support with it, then you can contact me. But I'll let you go with this key message from my talk. Thank you.
All right, so thank you very much. Now it's time for questions, but it's also the time for snacks. We have here a few sandwiches and drinks. So if you're hungry, grab a sandwich, please, while we are asking questions and then answering them. So I will just keep asking if someone has questions, and you guys, whoever wants to grab a sandwich, also do it. Let's see how it works.
Everybody who wants to grab a sandwich needs to ask a question first, right?
Maybe, yeah. So, are there any questions? Questions.
Yeah, I would like to know, I'm not used to English, sorry. I'm a software developer. I didn't get much of this Vortrag, yeah. I know the popular topics like ChatGPT, 11 Labs, or read the news about some rappers hacking a voice from another rapper, and then sell music about with the strange voice. You have an AI meetup, you say. Is this a meetup group I found on my meetup app?
Danko, you want to answer the question? Actually, I think it's a question to you.
I wasn't listening the whole thing. I didn't know it was a question for me. But AI meetup, yeah, we have an AI meetup in Frankfurt. We have a meeting every month. And this is one of those events now, today. So you are at AI meetup.
Another question: if I join a meetup there, are there people willing to found a company, maybe like 11 Labs? No, that was a joke. I think 11 Labs is just a big company. They have a subscription for $1. It sounds like I'm an advert for. They have a subscription for around $1. It sounds very cheap. It can afford every Hartz-IV-Empfänger can afford $1 in a month, but on a big scale, this guy, I don't know, maybe he's 24 24 years old, the founder of 11 Labs, where you can create your own AI voice. On a big scale, he is millionaire. He could be in 1 quarter, he could be millionaire. I just thinking in big scales, you know. I don't know if my skills are sufficient to build a company, to found. Long story short, do I find founding interested people at your meetup?
You could definitely find co-founders interested at the meetup. I think you should attend, talk to people, and there's good chances you can find someone with similar interests. Definitely. Yeah. There was another question. You have a question?
So I have a quite a basic question. So I have quite a basic question. This was an argument between me and my friend probably for the past 1 week. It was about going serverless versus going with server. It's a very basic question. And these days people are more preferring serverless for various advantages. For an initial stage, what do you recommend to go with?
Serverless.
Good, that's the answer.
Okay, take the simplest approach you can have, right? And with the less cost that gives you the most velocity and the earliest feedback so that you can give your product to your customers. So if that's the simplest approach, go this route.
Okay, thank you very much.
Thank you.
You have a question? No, not anymore. Not anymore. Anyone else?
Anyone else have a question? No. Well, I have one question. So you said at some point you told us that you have to have a model AI, but the model doesn't matter so much to create a product. You have so many activities around the model to create a product. Could you give us some estimate, maybe some real life example of something like that? And what interests me is the relative effort and relative amount of money that you need to invest for the model versus the round effort to create a product out of model. Time, money, effort, team size, I don't know.
Okay, so creating the model itself can be very costly. For example, the models that OpenAI uses, and they maybe charge you for that, they don't make money with it, right? They don't have anything left. They put the same amount that you give them also into the product, right? It's so in this way, the model is very expensive. And if I would ask a software developer, maybe we have some in the audience, what it needs to build all this around the model, they would say, okay, I can build it, it's not rocket science. But you need another skill set, right? You need a different skill set than AI practitioner. You need to have software developers, architects, operators, and so on. So it's not so much the cost, but it's a different kind of skill set that you need to bring to the table. But of course, having all these kind of skills and people in the project, of course, makes the product not cheaper, right? But maybe more successful, right? So if you only invest in the model and you cannot market it, you cannot bring it to your customer, all the money is wasted that you spend for the model.
We have one last question from Zoom. It's from Aiden. It's mentioned that data mesh is kind of self-service. How about when a team needs a tech which is not available? What happens in that case? Assuming there can be some limitations on premise, is it better to apply data mesh in the cloud? The another question about data integrity in data mesh, is it possible?
So actually, data mesh if you want to implement it, it's not only about the technology, but also about all the processes and the mindset of the people. So it's not really important where you build it. You can build it in the clouds, and of course, there are a lot of providers which sell their product with a sticker data mesh ready on it already, right? But this is not the most important aspect. The most difficult thing implementing data mesh is to bring people together, to make them build the right products that can be reused in the organization.
We start immediately.
Thank you very much.
Thank you for your attention.
Let us thank once again to the speaker. Sorry, we don't have time for more questions, but the speaker is here. You can talk to him. So our next speaker, please come here. Faisal, did I pronounce it correctly? So he will tell us about application of generative AI models of GPT. This is very, very interesting and fascinating topic. We have actually 2 talks today on this topic, except that I haven't seen the second speaker. Is the second speaker here? Please wave at me if you are. No, you are not. Okay, hopefully he will show up. Why is it so interesting now, Gen AI? I think this is because with all these large language models, we have one new unexpected type of technology, and we are all discovering now what is possible, what can be done with it. Everybody's impressed. Everybody says, well, lots of things could be done, but where exactly we will create the value, we don't know yet. And people are coming up with lots of cool ideas, and we are going to hear today from our speakers about their own work, about their own ideas. Right? This reminds me a little bit. This situation reminds me a little bit of like in history when a computer was invented. Right? Everybody knew, well, that's a cool machine, but they did not know immediately what we are going to use computers for, right? Or when the internet was invented, there was a similar situation, right? It was an amazing idea that you could send information instantaneously, pictures, text, and so on, but create websites. But what exactly it will gonna be used for? This needed some exploration, and to find out what the most optimal way of applying this new technology is. I think the same applies for Gen AI, and I think that the talks today are going to give us some insights on what people are working on, what kind of ideas they are having, what they are trying, and so on, right? So please give a warm welcome to our next speaker.
Thanks. Thanks. Okay, so yeah, my topic is not so technical, to be frank, because my idea was more kind of reflecting a bit on the meaning of generative AI for knowledge workers. So anyone who is not working in the industry, so to say.
Can you put microphone completely
Okay.
on your lip?
Oh, there. Okay. Is it better now? Okay. 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 Okay, thanks. Yeah, so Yeah, maybe one slide before. So yeah, as I mentioned, my take today is a little bit about how generative AI will impact knowledge work in general. I see a lot of young people sitting in the audience here, and I think anybody who is coming from university, fresh graduates or junior, going into looking for a job or making plans for career and so on, I think it's a relevant question. And I think while we don't know really all the answers, I think a lot is just spent on the hype itself. And that's why I would like to start by this slide here, stating that generative AI is a very interesting topic, but frankly, it's extremely overhyped. So if you think like a while ago, like, I don't know, 10 years ago, as people started talking about virtual reality, for example, I mean, we saw like what virtual reality could do. It's nice, modern graphics, but it was so overhyped that at the end of the day, we did not have any measurable improvements for businesses or day-to-day. So I'm not saying generative AI falls in this category, but I'm saying like generative AI is still making its early steps into development. As I will show later on, the type of activity generative AI tries to solve are still baby-like. So you would not be even able to do like a full task with generative AI. So it is a transformative technology, no doubt. It's probably going to have overarching and major implications to the economy, but we should not overdo it. I mean, ChatGPT is still quite stupid, to be frank. And this is still mimicking an impatient baby sitting on a table, not trying to withstand the urge to keep speaking, hallucinating, in whatever direction. So just to give it some kind of scope or some kind of note, this is still in early stages. No, it comes in the next slide. So ChatGPT just turned 1 year. It was launched 1 year ago. And don't let people kind of freak you out or whatever. This is going to be taking time. It's in the interest in a lot of companies, like if you see Microsoft and the big companies, they are themselves scared of this. So they are trying to scare you to buy their product, but it's really a hype. So don't buy into that. Still, there are very good results already, and there are a lot of things we can be excited about. So what I want to present today is also should not be taken as some kind of finalized way of thinking, but rather just a catalyst, a couple of ideas, food for thought to take, and also develop yourself and think further about it. Yeah. So what is generative AI? So yeah, generative AI or GenAI is a general purpose technology, and this is why I put it in red. So this is not virtual reality. This is not some kind of cryptocurrencies. This is something that can be applied to virtually anything. It's a general purpose technology. It's just as relevant and just as widespread and just as useful as the introduction of electricity. Okay? It also took electricity some time to be industrialized and to be turned into appliances and into professional setups that you could deploy safely. We will see something like this a bit faster, of course, because we are already post-industrial age, but this is as significant as electricity or internet itself, for sure. Yeah, so generative AI is a subset of AI, and that's why I have this circle below to show that the realm of AI is very fast and very vast and very wide. And generative AI is a subset. It relies itself on supervised learning, So it's still a newcomer to this whole bubble, but the whole realm of AI is much wider and has a lot more applications in other areas as well. So what it does is generative AI, as the word generating suggests, it creates content based on some training. So we feed it with a lot of content, with a lot of trained kind of models, and then it starts helping us to predict what we can do with our newly situation, real life situation. This works really good for text. It works really good for images. Images especially very interesting because we as humans cannot differentiate very well the differences in quality. That's why when you are playing, for example, 3D games over the network, there is a lot of lost data over the network. You don't really care because the human eye does not really dissect all the little details in images. So some of the progress that is done, for example, with Runway and with some of this generative computer vision based LLMs and generative AI models are extremely impressive. But that's just because we really are not very skilled as human beings in dissecting the differences. If we even probably manage to lose a significant portion of the data in the images, the mind would still actually extrapolate the data and make some sense of it. So some stats on generative AI. So there are a lot of studies, of course, from all the big four and all consultants saying how doomy and how bloomy the whole generative AI movement is. But maybe interesting is this report from Goldman Sachs that came earlier this year stating that the GDP implication, so productivity implication, worldwide of generative AI could be up to 7%. So that's really significant. We are talking about 7 trillion difference. A lot of organizations are already starting to look into this. We don't have any numbers on the success or failure of these attempts, but a lot of organizations are worried, maybe thanks to the great marketing of Microsoft, scaring everyone. But it's companies are looking into this definitely, and they are like 40% also a plan to put even more money on this. So what can we use generative AI for? And there is a large list of tasks indeed that can be used effectively or addressed effectively by LLMs at this stage already. So one of the things I really like, and I'm not sure if you are like me, who has been using the web since quite some time, I really like the fact that I don't have to click any cookies away. So if you work with ChatGPT or you work with any kind of generative model, there is no cookies, there are no different formats and styles and HTML for links or whatever. You actually get to the core of the stuff you want to do, and you don't care about any kind of cookie statement from whatever website, from ads or whatever. In my opinion, that's a purification, a cleaning of the web that was overdue. It was massively overdue. Now, of course, some of those bloating that happened to the web was driven by regulation. Regulation is, however, not a technology system, and some of the regulations end up just over-bloating the system. So that's something I like. I also really like the fact that search works not anymore in the sense that you get 10 million results from Google. And this is something I keep saying, and I've been saying for some time. Search was an unsolved problem. The fact that we are using Google as a shitty 10 million results page search engine is only because we don't have better systems for it. But the fact that there is no context, that Google does not know the context, Google does not qualify according to your experience, and does not strip away all the rest, and does not even give you like the most relevant result directly without like giving you without kind of overloading you with choice, it was not a good solution. So we did not solve search. LLMs is a highly welcome contribution to this regard. So I can only say that I use Google a lot less nowadays. I almost stopped using Stack Overflow since at least 1 year. And I don't regret it, to be frank. I don't regret it. I don't want to scroll 20,000 answers in Stack Overflow just to find the last one was actually no longer usable because the systems have moved on. That was crap, and thankfully it's gone away. Yeah, so to be also frank, like this repairing of the experience of the web has been also tried by some other people. Like the guy who created the web is also working on a product that actually kind of tries to solve this. But that's another topic by itself, so to say. Yeah, so there are three really use cases where LLMs currently shine. For the type of activities it covers. One is reading activities, so reading tasks, writing tasks, and interaction or chatting tasks. Reading tasks means things like summarizing, proofreading, translating, improving to a certain type of style, like making a paragraph more humorous or more businessy or more simple or more kids-friendly or more women-friendly. So that's something that actually it can do. And I'm so thankful it can do that. So yeah. The other thing is writing tasks. In my opinion, this solves one of the biggest knowledge work blockades, which is coming up with a starting point. The problem is not really creation per se, but just having a nudge to start creating. And if you have ever tried to make a presentation or write a book or write a report, you know the hardest thing is just to get into the flow. And these LLMs, how stupid and how random and understandable they are extremely excellent at giving you a starting point, a lot of starting points. So this is, in my opinion, a show breaker or a change of itself. And then chatting is based on the context. They can understand what you are talking about, and they will learn in the process, and they know a little bit better your problem, and they can kind of helping you. So that's actually great from that sense. And then you can see here, so I give an example. For example, you can do like, I don't like the title of my presentation. I ask it to give me alternative titles, and it's decent suggestions. Or I would like to translate this talk to other people in the audience who don't understand, let's say, English, so I do it in Arabic, and the translation is quite decent. Also, what is fascinating is these LLMs are improving at such an alarming rate or pace that even sometimes you will hear a talk like 2 days from some of the experts working on the model, and then you would like to check this after 1 week and it's already solved. So the pace of improvement is just crazy. Yeah. So LLMs come with a lot of opportunities. We saw before, they come also with limitations, and they come with some risks. But that's normal. Internet comes with risks. Electricity comes with risks. All new technologies come with risks, opportunities, and challenges. That's very normal. Don't let people scare you about this. So one of the limitations, but this is by design, not really by say to say nature of it, that many LLMs actually come with knowledge cutoffs, and we will get a bit shortly on how this comes to be and through the training. But if you ask, for example, ChatGPT to tell you what's the cutoff, it will tell you I learned up to a certain point. This is, of course, can be challenged or can be augmented by using the browsing capabilities of ChatGPT. Sometimes they can learn, but some of the aspects you will notice that actually that it's trained within a given cutoff. There are, of course, also the issue that, but this is the nature of LLMs, that they start making things up. So they start hallucinating. So it's not only, you cannot just trust it blindly as the poor lawyer in, I think, Los Angeles did, that he just created a case and submitted to a judge who was surprised that actually none of the cases were actually there or have any relevance. So you have to be careful what actually it's outputting. And there are, of course, technical limitations, like the length of the input, the length of the output, or together what's called the context. And also, currently, LLMs are quite good at unstructured data, but not at analytical data, like tables, time series, and stuff like that. It's probably going to be changing, and when that changes, then we will see the real impact. So I do assume that if LLMs can understand time series data very well, well, some of the jobs like investment analyst and asset management can be in danger. And also the fact that LLMs just reflecting the content we teach it, which is produced by humans, so it inherits also our biases and toxicity along with it. And we can see here like the potential for the implications. So this is an example for applying LLMs or automation, AI automation, to a call center, for example. And people will usually try to give you like this impression that it's a 0 or 1. But reality is this is a spectrum. And it goes from a complete automation where only AI is acting to a human-only kind of type of work. So just keep in mind, it's usually not Boolean, it's not 0 or 1. Usually there is a spectrum, and any job will be partially automated or augmented, or it cannot be even automated. So usually there is no such a thing as we are doomed or we are not doomed. It's something always that is some kind of spectrum. Yeah, so I show you here some kind of limitation. This is actually an interesting example. And it shows a little bit this side of the context of LLMs. So if you are a little bit familiar with the investment world, you probably have heard that Charlie Munger, who is the partner of Warren Buffett, died 2 days ago. Now, if you just come directly without any kind of context and ask ChatGPT, can you tell me like what Charlie Munger will be talking about in the next shareholder meeting in Omaha? And it will start, okay, probably like always, it will talk about these topics. Now, if you go to another window or restart this discussion and tell it, can you tell me where he is living now? And then it will figure out that he died. And then if you ask it the same question, it will tell you like, he is not going to be attending next year's shareholder meeting because he has already passed away. So the way you provide it with the context, it also affects the way it will give you the information that you can actually use. And this is just to keep in mind. So you do need some kind of loop. You need to interact with the LLMs to give them a little bit of context. Teach them if you would like some quality answers. Otherwise, you can really get an unexpected answers. And we don't know how they reason or if they reason at all. There is some kind of at least feeling that they have some kind of reasoning capability, but you need to help them in that case. So it's more like a small baby, as I'm saying. Well, I'm not like who can speak like a little kid. So large models, what are these things? And I think the guy before talked a little bit more technical about this, but I just want to kind of, let's say, take the mystery out of this. It's not really that complicated or rocket science. Not that rocket science is actually complicated. It's just ballistics. It's just something that goes and goes down. So the implementation of LLMs per se, it's actually extremely simple. You can write it. Anyone on this audience, if they can get this structure and they know a little bit of mathematics and how they can program, I don't have any doubt that they can probably implement like such a network. So the example I'm including here from Andrej Karpathy, it says that the implementation for the Llama 270 billion parameter took around like 500 lines of code of C. But you have to remember that C is a system language. So there is a lot of memory management, there is a lot of pointers, there are a lot of... So it means if you would like to implement it in Python or in a higher language, this is actually way, way, way shorter. You can actually do it probably in 100 lines or even fewer. So this is like the implementation. Now the part which is really expensive and where this whole money and crazy kind of investments come in is how do you fill up. So if you have a 70 billion parameter model, you would like to initialize it with some kind of state of the world, okay? And for this a part, and it's also amazing because this graphic does not come from me, but many experts keep actually confusing internet with the web. Nobody is taking the internet, but it's only the web. It's just text on the web. So what we do usually is we try to collect as much information as possible from the web by just creating a web scroller. Go into Google, copying pages, saving it, something like 10 terabytes of data. Okay, and then we use that to train the models themselves. That's a lot of data. And for that, you need some kind of high-performance computing infrastructure, GPUs in this sense, to train it over days and days and weeks, and even like it could take like several weeks. And here, that's where the money is. But this is like not really the this is just data and compute. So there are of course a lot of practical things. How do you really There are a lot of low-level details and so on, but this whole money going on is really just on compute and letting the models work, so to say. Once this is done, the next step is the fine-tuning. This is where you have some kind of state of the world in your mind. Now you would like to teach it a little bit on real-world scenarios. Somebody comes with this, turns this model into an assistant. So it will give you, if you give it an answer, a question or a prompt, it will then learn how to use this base knowledge of the world together with the trained data you give it to provide something that is relevant to your situation. So this is LLMs. This is like the mathematically speaking, not so complicated. The complication or the effort is more kind of collecting and running the first base world initialization and calibration. And the last one is actually not so expensive. You can do it every day. Usually people do it on a week in, week out, so to say. So let's skip this slide. It's a bit about the transformers. So just to explain this like in 2 words, the magic behind LLMs is this construct here called the transformer. And there is a paper that actually introduced this concept called transformer attention is all you need. And the funny part about this, and this is where also the magic come in, is mathematically speaking, we understand actually how this works. We understand what each gate does, what the interaction is, and so on. What we don't understand is how the decisions afterwards, so once this is trained, how the decisions are made. That's something we don't understand. It's kind of sounds rational, sounds convincing, but we don't know how the weights, how those weights inside of this huge kind of data structure kind of collaborates to give the answers. That's something nobody understands yet. And we don't know if there is some kind of hidden logic in it, and we don't even know if there is a language in it. So that's where a little bit the fun part with LLMs is. So a question probably that is in the mind of many of you is, why do we keep getting those large numbers? Like, why do we have like a 70 billion? Is it Super Size Me, like some American game or whatever? And the reason for this is actually very simple. So this comes from another paper that basically says there are 2 ways to improve the performance. And with performance, I mean how good the answer of an LLM model fits to the answer that you are expecting. So this is called a loss function. And this loss function for LLMs, as data structures as they are, it's actually quite smooth. So it's differentiable, it's easy to maximize and minimize. So we figured out actually this loss function, or the efficiency of this prediction, depends on 2 major parameters only. One is n, which is the number of parameters of the network. So how many go in, or how many parameters are in the network. And d is the amount of data we feed it. So it means, computationally speaking, the more data and the more parameters we put on a model, the better the efficiency and the accuracy. So the accuracy of the prediction is. So this actually, so you can of course go and try to change or improve the algorithm itself, but this is a sure way to go there. And if there is like this rush, gold rush kind of movement, everybody is trying to be better than the next, this is what we are actually witnessing. Like everybody is just putting data and making the networks better because that's an almost certain kind of indication that the prediction or the quality will be better. So there is no kind of magic behind this. Okay. So yeah, so maybe back to the main topic of this talk. So this is all good and nice, but whose job is this going to be taken away? And I put this screenshot in the middle because, and this is where you have to be a bit careful with what experts say. So the lady, without going too deep in the specifics of her profile, she is a famous character in Silicon Valley. And she had this talk this year still, because everything is new, where she tried to answer this question, and the answer was, well, it's easy. Oh, and not that easy. I mean, we should not exaggerate. But for her, the job that's going to be automated away is the job of software engineers. And in my opinion, that's, has some truth in it, but it's also completely simplistic. One is, I think a lot of people, even in Silicon Valley, confuse computer programming with software engineering, which is completely different two things. Like generating code is not software engineering. A software engineer does a little bit more than that. And the other thing, this is taking software engineering by face value, which means many people think the job of a software engineer is actually creating software. Yeah, but why do we call it soft? The reason we call it soft is because it's a knowledge artifact. It's a knowledge product. So if you take any type of knowledge work, let's call it, legal or whatever, you can actually structure the workflow of how these people work in a very similar fashion how software programmers or software engineers work. The only difference is software engineers came up with languages they can use to program and deterministically execute products. Those people don't. But now with LLMs, this does not play a role because the overarching language is natural language. So, in my opinion, the software engineers have the same danger as. Okay, good. Okay, but anyway, we want to have like a more serious way of thinking about this, and for this, there is actually a framework that was suggested by a professor from MIT. Eric Bryn-Folsen, who actually came up with a better way of thinking about this, which is a job is not some kind of atomic unit, like it's 1 or 0, but it's a set of activities that you can then order in terms of how likely it will be automated or not. And I think just be aware of time. So this is some examples. So for example, you can see a computer programmer, what they do, and then you can rate it. This is high potential for automation. This is low potential for automation, what a lawyer does, what an investment analyst does. Finally, I could also ask ChatGPT to tell me like the activities of jobs and rate them. So yeah. So just again, my point, don't think in zeros or ones. Think always in spectrums. Jobs are sets of activities and workflows, and usually there are no jobs that will be completely, or almost no jobs that will be completely automated away just like that. So we have some studies actually how this is going to be affecting the job market. And here there's a report that says that actually GenAI will be affecting higher paid jobs more. And you can see this. So the annual wage and on the y-axis, the exposure to AI. And you see actually that's the upper side. So there is a lot more kind of exposure to AI, the more the salaries become. This has just kind of value. I mean, this does not say that the other jobs are not eligible for automation, just means that jobs with higher wage have more incentives to be automatized than others. So, and this is again the same thing, but now by function, by job. And you can see that's also a little bit the impact as a percentage in terms of spend on these jobs and the impact in terms of billions. And you can see, and this is the alarming one, this is the talk, that almost or more than 70% of the impact will be in knowledge workers. So knowledge workers, you have to be careful. So yeah, so that was that. And there is also an impact with industry. And you can see wherever there is creation, reading, writing, and stuff like that, or interaction, these people are, of course, endangered by generative AI. So yeah, so what can LLMs do currently? Now let's talk about it at a higher level, not only like kind of mechanical work. And this is where I think it's useful to think about this in this framework that was introduced by Daniel Kahneman, the economist, who differentiated in his book Thinking Fast and Slow between two types of activities we do. So system 1 and system 2. So system 1 is everything that is automatic. It's you don't even think about it. It's almost subconscious. You don't deploy a lot of intellectual capacity to it. And system 2, everything that has a higher level of abstraction, deeper thinking, and so on and so forth. And actually, I think I reiterated several times that LLMs kind of seem to be like this impatient little kid. So this all kind of corresponds to system 1 type of activities. You ask it, it doesn't take time, it just answers automatically, probably a lot of rubbish, and then you need to ask it again. So we are still at system 1 currently, which is good news. Yeah, so I will skip this for the interest of time. Yeah. And yeah. Okay, let's also skip this. So how to think about LLMs. And I present, so when we would like to evaluate the side, like the effects of a given technology, we have to have some kind of way, some reference to think about this. And I came up with 6. So it's not 1, it's not 2, I came up with 6. So you can think about LLMs as some kind of mental model. And you can do that because the transformers behind LLMs are just mathematical constructs you can use for daily work. If you understand how transformers work, you can use them also in comparison to others like Monte Carlo. These are just basically mathematical tools. So, but LLMs can be also seen as some kind of web chat interface. So what ChatGPT, for example, is. So some kind of web interface, and that's it. And many people try to sell this, like, for example, Microsoft. Like, everything's just an assistant to integrate it into current product, and that's it. Yeah, no, there is more to this story. So LLMs could be also thought of as an API, kind of an application programming interface, which means this is not a danger to programmers, but this is just another toolkit that you can use and build applications with it, interact with it, do all types of things with it. LLMs can be also thought of as a platform. So if you think about, let's say, Salesforce or some of the products that come with their plugins and their many apps, well, what actually Sam Altman showed recently was this app store for LLMs. And you can think about this is a platform. So you have a lot of specialized plugins, but you can also think of it as an operating system. And I think this is where things get a bit dangerous to Microsoft, and I'm mentioning Microsoft a lot, maybe it's not intended, but LLMs have the potential to replace operating systems entirely. And I will get in more details into this. There is even one more. LLMs actually have an integrative function. So there are a lot of LLMs that can talk with each other. They can actually create a completely new computing paradigm I call experience computing, where intelligence is embedded, but not kind of mechanically ordered, so to say. Like when you go with travel, actually you really don't care about the app of MVG here or the transport. You don't care about the chicken app. You don't really care about the airplane app. You don't care about the hotel app. The only thing you care is about a continuity of experience. And LLM can provide this intelligence in the background, seamless integration of intelligence. Okay, so LLM as an OS. This also coming from Andrej Karpathy. That was also okay. So you see that on the right there is the traditional computer with a control unit, with memory, with peripherals, and you can think actually where LLMs are going. The same thing. There is a model in the middle, which is the CPU, some kind of the LLM, and there is of course a context. We know there is some kind of memory in LLMs. We know it can actually interface with video, with audio, with text, and so on. So you can think of this just as an evolution of operating systems, not built on chips, but built on data structures that actually reflect knowledge. So now you can really think about computing and operating systems just the next level. Now this is a funny part, because in LLMs we know the language, we don't know the logic. So what you can think about is actually we are coming from a large logical machine. So these are the deterministic types of machine. We are moving into the large language machines, which is more kind of the fuzzy logic type of world. And it's a fascinating world. It's a fascinating world. And I do believe that we are going into this direction. LLMs will replace Windows. And this is what Microsoft does not want to hear. And I put another illustration just to bring this to the point. Maybe it's not a coincidence that the guys in OpenAI create this thing called prompt that could more or less match the initial kind of revolution in personal computing with the MS-DOS prompt. So it's basically the same command. You have a prompt. So that's the language, that's the command. And what comes afterward is the proliferation of languages and ways to interact with those systems. Now the last one is LLMs as a powerhouse for a new computing paradigm, and this was announced a few weeks ago, Humane, where actually this intelligence was seamlessly integrated into an ecosystem that actually comes behind this pin here, where you have a seamless experience doing all your activities, not caring about which app is actually in the background or which kind of technology. And I think we are here. We need this because the web is bloated. The app economy is failing. I have 20 or 30 apps in my smartphone. Maybe I only use 2, and usually it's the web browser and the email. And smartphones are leveling up. So maybe we are into actually the next kind of computing level with this. Okay, so there are some safety and security issues, of course. So what to make of this now concretely? This is my last slide, no worries. So this book came from Cal Newport in 2016. And he was a bit earlier of his time because he said, given all the advances in technology and in efficiency, it will be the only kind of 3 types of skills or jobs will survive in the future. And he puts this in 3 types. So high-skilled workers, superstars, and entrepreneurs or owners. And he's actually of the opinion that you should focus on high-skilled workers. Because he says, owners, well, that's difficult. Superstars, that's difficult. So maybe you should go for high-skilled workers, and that's why deep work. You need to focus. You need to do more. Like, don't avoid instant gratification, social media, and so on and so forth. And I have another thesis to this, and I think that used to be a good estimation. But I do think that we are in an age where the next real job will be entrepreneurs. Because now imagine you have all those LLMs as experts in your team, and you can have as many of them as possible. You can have your legal expert, you can have your marketing expert, you can have your copywriting expert, you can have all types of experts in your team. I do think that this is going to be giving the rise to a crazy abundance in entrepreneurship, like none before. And this might sound a bit kind of surprising, but I think many people forget that just a few years ago, like 200 years ago, entrepreneurship was the go-to kind of state. If you came to the world, you were let's say a bawa, so you were people still farmer. Sorry, thanks. You were a farmer, you were a smith maker, you were all types of things. So this entrepreneur as a default state of the world, it's nothing revolutionary. That's how humanity used to be before industrial age. And we have the tools to go back, but do it better, way better, at the knowledge work level. And yeah, that's it. Thanks.
Thank you very much. That was excellent. I enjoyed it a lot. Are there questions? Questions. Yes.
Thank you for the talk. As you already mentioned, the input really influences the output of the model. Do you have some suggestions or thoughts how to create really great query that not influence a lot the output and gets more fair output or something more? How to create a really good query that not influence a lot the output of the models, and like how to create great query.
So if I understood the question, you would like to have like tips or recommendations for prompt engineering to avoid such hallucinations, you mean? I did not get into the talk, but prompt engineering is now some kind of an extremely evolving realm by itself. And the tips is you need to give the model as much context as possible. So nowadays, I think in the last GPT Turbo, you can even put an entire book as context, as a prompt for ChatGPT, and it will analyze it. So we are growing extremely fast in that respect. But basically, you need to give it as much information as possible. If you give it little information, it will try to do its best, but the best based on little information is more stochastic. So I would say be explicit, be extremely... I usually write, if I would really to have a structured answer, but there are limitations. The thing is, it's always a return on investment. Sometimes you are very specific and then it tells you, well, I can only offer you 10 options or whatever. So you have to... I had a graphic there I took out, but you have to do this iteration. You have to do a prompt, see what it gets, then feed it again. You have to try it, just to iteratively try it. But as I said in the beginning, this is not final, like we are still learning. So be experimental, play with it. It's more kind of a playground currently. I would not do the mistake of the lawyer and send the cases to the judge without even reading what it was saying. That's a bit maybe not so smart.
More questions? Well, then I would like to thank the speaker once again for this excellent talk. So we will continue immediately, although we have in the schedule, it says a break. We already did our break. We had our sandwiches and drinks. So we will continue with the next speaker. Hi, Dan. So Dan was our speaker last year at ITCS, right? So it's already a tradition to have Dan here at this event. So he will also talk about Gen AI, about his own view. I'm sure they have some really good ideas of what one can do with large language models. And I'm very much looking forward to see that. So let's give a warm welcome to Dan.
Super. Can everybody hear me? It's great to see you all here. I have a couple of... All the way to my mouth. Okay. Great. Wonderful. My name is Dan Fitzpatrick. I have a fun topic for us today. We're going to be covering a whole bunch of different things, and I hope that there are some surprises for you in there. The first surprise is that I am sometimes schizophrenic. I've brought a lot of little identities today of myself for you, and I'm going to be talking about that right now. First of all, I work obviously in the IT branch. I run a small company here in Frankfurt, a startup, and we do conversational AI. So I'll be talking about a lot about that today. But what I am not is a human relations expert. I'm not really into hiring, although we are hiring. I'm also not here as a programmer, although I programmed for about 20 years. I'm also not here as part of an international network, although that also plays a role in my career. I'm here today as your new boss. So if anybody out there is looking for work around conversational AI, if you think that this topic is interesting, why, I'd love to hear from you. Right now, though, I'm going to switch into my next identity, and that is your favorite pizza chef. I'm going to teach you all today how to order a pizza. Has anybody here ever ordered a pizza online, in the pizzeria, on an app? You're going to relearn how to do that today. So, moving right along, we'll start off with the agenda. I hate agenda slides, so we're just going to jump right over this one. But please take a second and see how I put the emojis on the bullet points. I'm really proud of that. So, moving right along, let's talk about recipient design. What is it? We're going to go a little bit into something called sociolinguistics right now, because we need to find out what the differences are between how computers talk and how you and I talk to one another. It's not a new field of study. It has its roots in something called ethnomethodology. You're all students, you're used to big words, so I have no problems with that. Ethnomethodology is looking at how people interact socially and then deriving social structures from that analysis. And among those analyses are how people talk to one another, because we want to enable computers to talk in a more engaging manner. So what they did is they started analyzing telephone conversations, because they obviously wanted to enable people to talk to automated systems. But because people talk differently, they had to start with something. And that was the material they used, and they found out some really fascinating stuff. Moving along from telephone conversations, they expanded the field of study to include the field of medicine, law, and many others to find out how do patients talk to doctors? What's the context there? What are the special things we need to take into consideration? They found out that humans have an economy of turns when they're talking. When computers talk to one another, it's all ones and zeros, and we know how much data is going back and forth. But when people talk, the more they get to know one another, the more compressed their conversations become. Analyzing how that happens is a big part of recipient design. They even started an institute to study how people talk to one another. I think that's pretty important and a pretty significant realization. They came up with ways of analysis to find out how do people talk to computers. Because if we're going to enable people to go into, for instance, automatic voice recognition applications when you're talking on the telephone, we need to find out how do people interact with computers. How do people interact when computers are around? Also very, very important. They even started to find out how can we use conversational analysis and recipient design to design better conversations between people and computers. So they kind of built the bridge between this field of studies and conversational AI, which is what we're going to talk about today. Studies, this is an expanding field of study. It's continuing along, and every day we get new insights into it. Every day I learn new things about it, one of which is called conversational analysis and power. We'll be talking about that briefly as well. So let's get into a little bit more detail. You all have used chatbots in the past, I'm sure. Oftentimes, the experience is terribly frustrating or disappointing. And I run into a lot of customers that say, no, I don't want a chatbot. I've been trying that for years. Nobody uses them. Well, of course they don't, because they don't talk like people. They misunderstand. They lead you into a dead end. They give you too many options because they don't know how to use sociolinguistics. They don't know how to use recipient design and conversational analysis. You're saying, yes, I'd like to order a pizza. Well, that chatbot is going to say, I think I heard the word pizza. That's all it understands. So we'll go from there. And then after that, you go into the linear conversation. And the context is also very, very limited. With the advent of large language models, the context of chatbots has been globally expanded. We'll be talking about that a little bit as well. Human conversation, like I said, is based on an economy of turns. I'll give you a short example in just a moment. But we've been talking to one another for quite a long time, over 1 million years. So we bring 1 million years of evolution and intuition into our conversations. Computers can't do that. It's going to be quite a while before they can, but we're working on it. Humans have context-driven conversations. We have intuition. We have all of our senses in the conversation rather than a simple chat window or a voice interface. So let's talk about the next generation of chatbots. We're going to use something called condensed statements and give the chatbots a memory. We're going to use generative AI so they can speak, they can express themselves using terabytes of human context. We're going to use artificial intelligence to find out what does the person want. Do they want a pizza or do they want to buy a new car? So we don't have to go down a linear, strictly ordered set of intent recognition algorithms. We can use Gen AI to get a much better understanding of the context of what the human being is bringing into the conversation is. And obviously, using that context, we're going to enrich the conversation and the experience for the computer user. Starting with the old approach, all of your computer interfaces use something called, I'm going to call it audience design. For instance, I know I'm talking to a bunch of students today or people who are really looking for a job in the IT industry. So I can design my talk around that audience without knowing each and every one of you individually. But does that go far enough? I'm talking to a group of people. I'm not talking to you individually because I don't have the detailed context to do so. That's very, very important when human beings talk. And when designing computer applications, all of your conversational and user experience architects work with something called a persona. They come up with a fictive personality to describe their user and to describe their system. But once they've done that, it's nothing more than a guideline that sits on the shelf and gathers dust. A static persona helps you to determine, okay, my application is friendly. It's enthusiastic like a travel agent, or it's serious like a psychiatrist. So I define a personality for my application, and that's it. It just stays there. It never changes. All the dialogues in the system, be it a chatbot or a voice recognition system, are hard-coded. Enter your last name now. Can I record the conversation? Bringing you closer and closer and closer, hopefully, to your goal. It has a single tonality, like I just said. It never changes. So if pizza is the subject and I am your pizza chef, maybe I'm enthusiastic. I know who you are. I talk to you every day, but I can't respond to an individual situation because my personality has been anchored in a set of guidelines and never changes. It offers a static experience. Fine, it may be well tailored to the brand message I'm trying to deliver, but it is nonetheless static and never changes, and it certainly doesn't change within that one session when I am using the computer application. Recommendation algorithms. You've all been on Amazon, you know about it. People who bought this also bought that. I don't want that. I want an offer which is tailored to my individual needs. I don't care what my neighbor purchased. I want to know what's good for me personally as the individual recipient. Obviously, you can use my shopping history. You can use other long-term data to make a fuzzy determination about who I am and what I want, but it certainly doesn't go into the level of detail which is possible in a human conversation. Like I just said, the interaction is linear. It starts, it gathers information, you put something in your shopping cart, you pick your shipping address, and you send it off. It's a linear experience. People don't talk in a linear experience. People talk on a multi-point contextual experience. So we can work towards that goal to try to make the experience better for everybody. So we're going to move away from audience design towards recipient design. What is that? Recipient design is me talking to you personally. It's me talking to everybody on a personal basis. And in order to do that with a computer application like a chatbot, I need to gather as much detailed context as I can. We're going to be talking about that in some detail. I take the input from the user, obviously, and I gather more information that might just be the actual content than what has been entered into. I enter into the context and I read between the lines. I go into the session data, but I go one further. I don't just look at what products maybe the person has looked at. I don't just look at what questions they have posed, but I find out how long have they been looking at my informational offer. Are they jumping back and forth because they're uncertain, or are they directly moving into what they want to find out? I use that to enrich each turn of the conversation. And in doing so, I make the experience more personal for the user. And when I've done that, I can enrich the output. I can tailor the output on a session-by-session, on a sentence-by-sentence basis, using each conversational turn to make the output detailed and hyper-personalized for the user. We'll be talking about that in a bit. I make my recommendations from the system not based on what everybody has purchased. I make my recommendations based on your behavior when you're using my application. I make my recommendations by reading between the lines to make an educated guess not only about what you want, but how you're feeling at the moment. Very, very important. I obviously can tailor output by using dynamic speech. I can change the modulation of the speech and make it higher or lower pitched. I can make it faster or slower. And I can generate a more engaging experience by doing that. And like I said, a compound turn flow. Very, very important when you think about human beings and how they speak to one another. Hi, my name is Dan, and your name is?
Anastasia. Anastasia.
Anastasia, thank you. What we just did was recipient design. If this charming young lady had just gone into a computer application, it would have said something about, please enter your first name into the field, and this is an obligatory field. And she would have done that. That was the cue and her response. But it is a single turn conversation. She was prompted and she responded. What we just did is something called a multi-turn conversation. I gave a prompt, but I didn't explicitly ask her for her name. I gave her the context, and she automatically responded with her name. So you can condense your conversational turns to make a more engaging experience. That is the way people talk to one another. We use cognitive AI. We can analyze the context of the speech. We can analyze the content of the speech and then send it through an emotion AI algorithm to find out, is this person enthusiastic, happy, sad, or irritated? And we can feed that information back into the conversation and tailor our answers for the person to make it a more personalized and engaging experience. And what happens to our personality? It's no longer static. Now it responds more like a human being would. It responds with enthusiasm. It finds a product. It knows that maybe I'm looking and I don't understand what I want and gives me a recommendation accordingly. So I talked about hyper-personalization, and that's important because I like me. There's nobody else out there like me. You all like yourselves. And if I'm having an interaction with a digital application, I kind of want to feel liked. I want to feel unique. I'm not part of an audience. People who bought this also bought that. I am me. I don't want to be part of an audience. I want to have an individual interaction with this system. And in order to do that, we're going to use recipient design. We can infer situational information. Like I said, is the person in my online shop or in the pizzeria or in the app scrolling and scrolling and scrolling because they can't find what they want, or have they automatically found the product they want and are going right to checkout? When I realize that, I can tailor the conversation to their needs. I ask engaging questions. Hey, I see you've been in the app for 5 minutes now and you haven't really made a choice. Did you want a vegetarian pizza or did you want something with sausage on it? Carry the conversation forward by asking an engaging question, even though the person has said, I can't decide what I want. We process those cues and we give contextual information back. We do so also on a semantic basis, obviously, the meaning of what the person said. I want a pepperoni pizza, fine. I know what that is. Having gathered that information, okay, what would you like to drink with it? Carry the conversation forward by using a semantic cue. We also process contextual cues, and this is something that human beings do very, very well. I'm up here on stage, I'm speaking in an animated manner, and you're listening to me, and by listening to the tone of my voice, the speech that I'm giving, it kind of comes to life a little bit more. I can speak faster, I can speak slower, or I can end every sentence with an exclamation. By listening to me, you are receiving more information than what I'm delivering, because your ears, eyes, you know that watching somebody speak delivers a lot more information. Body language, things of that nature. So processing semantic cues, syntactic cues, but also behavioral cues. Am I in a hurry today? Maybe I'm a little short fused because I didn't get any sleep last night, or maybe I'm enthusiastic and I'm ready to make a purchase. These are all things which we can pick up on during a conversation without having an explicit instruction from our conversational partner. Biometric cues. There was a university in London a few years ago. They actually were able to determine the emotional state of a test candidate by bombarding them with radar waves. So emotional and biometric cues are also very, very important. If I'm speaking in a very rapid manner, you can kind of understand I'm looking at my watch and I really need to get back home tonight because it's Christmas Eve and I have a party to go on later. So just by the way I'm speaking to you, you can understand there is more context to my personal situation than I am delivering semantically. Having processed all that information, we aim for an exclusive tonality. I want to make every guest in my pizzeria or my online shop feel that they are unique and the tonality is adapted to that person. So if I see that somebody's really a pizza lover, then maybe I'll spend a little bit more time talking about pizza with them. And if I see somebody's in a hurry, I'll say, hey, what's your order? There's 10 people behind you in line. Let's get moving. Context is king. And when we do that, we feel like we're being treated seriously. We feel like we're having a better experience. So when I say to my wife, hey, let's go out for pizza tonight, she wouldn't say, fine, look in the app and find a pizza parlor. She'd say, no, we're going to Paolo down the street. He likes us and he understands us. But we also never want to overreact. So if I go to Paolo And I say, Paolo, I need a pizza right now. I'm in a hurry today. So, okay, what's the problem? And I say something like, well, yep, my house burned down and I have no kitchen anymore. If Paolo said, well, that's too bad, let me get you a pizza, I probably wouldn't feel like he was taking me seriously. Paolo might say something, oh my God, your house burned down. That's a tragedy. The pizza's on the house. Because he'd understand the context of my emotional situation and respond accordingly. But if you over or underreact, which emotion AI systems are sometimes prone to do, then your recipient doesn't feel like they're being taken seriously. So I want to be taken seriously. I want to feel like I'm being understood. And talking to a chatbot that has just sent you into the third dead end because it doesn't understand what kind of pizza you want doesn't make you feel like you're being taken seriously, doesn't make you feel like you're being understood. So I'm going to try to infer personal information, like I said, by finding contextual cues in the conversation and responding to them. I'm going to speak the user's language. Listening to two teenagers talk to themselves. I have two sons myself, and listening to teenagers talk to themselves, it's a foreign language. But if they start talking to me, then they might change their tone of voice. And if I try to be like pseudo cool, I'll try to talk like a teenager and sound like a complete idiot. It just doesn't work. We'll be talking about that in a minute, how different contexts and different relationships play a role in conversation. So you speak a user's language, make them feel understood, use their terminology if you can do so in a proper manner. Find out what the other relevant information is. So I'm in the pizzeria and Paolo says, what is it going to be today? Would you like your normal pepperoni pizza? I said, no, I need 5 pizzas today. He might assume, okay, I'm cooking for my family, I'm having a party, but then he has more information about me. And to tell you the truth, 4 or 5 things, just by entering a pizzeria, Paolo knows about me. Well, I'm hungry. Maybe he knows I like pizza. I certainly like Italian food, otherwise I wouldn't be in there. I'm ready to order, probably. And maybe I'm not in the mood for sushi. 5 facts about me just because I walked into a pizzeria. This is what context is all about. You can also detect how educated a person is by listening to the terminology, the way they put their sentences together, and you can respond accordingly. You can also, we did this in a workshop, and there are up to 25 individual personal aspects about me that you can infer by the way I talk. Not what I say, but how I say it. That's very, very important, and this is something which almost all chatbots worldwide simply do not do. But I do, and I'll be telling you about that in just a moment. Within certain parameters, you can estimate the age of the user. Hey, I went to a conference, it was mega cool, and it totally blew my mind. I put that into ChatGPT, and I said, okay, how old am I? And it was within about 15 or 20 years able to understand that I'm still 29 years old. So what we do with that information, like I just said, we make individual responses. We establish a wavelength with the person, a connection, which to take an initial customer and turning them into a loyal customer is very, very important. So we've been taken seriously. We're understood. We are unique, but I don't want to just be unique. I want to be remembered. And this is one thing that human beings do exceptionally well. We have to, in order to survive in a social context, we have to remember our conversational partners. Computers can do this, but only in a very limited manner. I want to feel memorable. Who was that guy, Dan Fitzpatrick? Never heard of him. I think I met him, but that's kind of disappointing to me. That hurts my feelings. I want to be remembered. People do this using long-term memory, and so do computer systems. We use cookies. When was the last time I visited the online pizzeria? How long did I spend there? What did I order? This is all very, very important contextual information. That's long-term memory. Customer relations database. What have I ordered the last 10 times I've been there? Do I get a calzone every Tuesday? This is important information which should flow into the conversation. Short-term memory is even more important, though, because when we talk, every sentence we exchange, every turn of the conversation goes into short-term memory. So I can say to Paolo, hey, today I want mushrooms on it. And he knows I'm not talking about my feet. He knows I'm talking about a pizza, but I can say the word it, I can use a relative clause, I can use a pronoun to describe what I want because we have a common shared short-term memory. Session data can help us out to find out how long has the person been there, what are they looking at, is there something I need to react to within the context not only of my entire history with the customer, but this individual conversation. References and semantic context, I just touched on that. Would you like a glass of wine with that? With what? Well, obviously with the pizza. We're in a pizzeria. The context is pizza. I just ordered a pizza. If he's saying, would you like a glass of wine with that? Fine. And if I order a pizza bianca, he might say, hey, our white wine, the Pinot Grigio, you should really try that. But today I'm in the mood for Montemare. He'd say, I have an excellent Nero d'Avola for you. Try that instead. Context-based, based on the situation and not my entire purchase history. So we conduct efficient conversations. I'll be talking about this a little bit too. Human beings converse very, very efficiently. And when I'm interacting with a digital application, if I could be more efficient, better understood, I certainly would. It makes your conversational partner feel relevant. If you will go on a date and you forget the name of your date, they're not going to feel very relevant, are they? So you want to make the person feel valuable and relevant. Establish a connection to the person who's using your digital application. Make it more user-friendly for them, and they'll come back in the future. Who is speaking to whom? Very, very important, because relationships play a very, very big role in conversations. How do I perceive my conversational partner? Plays a big, big role in determining how I talk to them. There are two different types of perceptions, one of which is difference-based. I talked about the teenagers. So parents talking to their children, professors talking to their students. The relationship often gives us a guideline for how to talk to our conversational partner. And that is a difference. There are others involved, obviously, social context, a mother with a child, like I just said, a professor to their students, but an age difference, very, very important. Differences in level of education, or let's say if I meet somebody in downtown Germany and the person addresses me in very broken German, I would probably understand this person is a tourist and change my speech output accordingly to help them better find their goal. Differences in gender can also play a role. But there are also similarity-based relationship cues which help us to guide a conversation. A common group of people. You are all at the fair today. You're all probably students. You're all looking for a job. These are contextual cues which bind you together. They make you similar. And when you're talking among one another, you already have a context to start the conversation. You probably wouldn't start the conversation about the weather. You might say, hey, what exhibits have you visited today? But shared history is also important, talking about the weather. What were you all doing in the snowstorm yesterday or the day before? I was in the mountains and I was driving in a car on summer tires because being poorly organized, I have no snow tires, and it was a horrible experience. But we all know what the weather is like outside. It gives us a common history to talk about. This is why so many conversations start off with, hey, do you like the weather today? You're trying to find a commonality with your conversational partner to get the conversation rolling forward. So you have a shared history. Everybody has a shared history which you can talk about. And also, this is something which is a very, very important aspect. People have a common goal, and working towards that goal together gets us away from natural language processing towards something called natural action processing. I want to have a delicious pizza, and Paolo wants to make me a delicious pizza. We have a common goal, and from that context, both of us will steer the conversation accordingly. So Paolo says, that'll be $7.95. I wouldn't say something like, I only have €6 and I'm not paying you $7.95. We have a common goal, so I will pay him his money and I will get my pizza. Context. Let's talk about this in a real life application. We're working on a customer project now, and they are moving into a new sales model. It's an automotive company, and they are moving directly into online sales. And people who've purchased automobiles know that usually you go into a dealership, but all big auto manufacturers offer a car configurator. So online, you put together your dream car, take it to the dealership, and then the dealer places the order. Well, they want to allow people to directly purchase their vehicles. But they have made a big determination, and this is worrying them because they have taken those configurations and compared those to the vehicles which are actually purchased in the dealership, and see the vehicles purchased in the dealership are more luxurious, and they're more luxurious because they have better options, and options mean profit. So they don't want to lose that margin. they know that the dealer brings a little bit of magic into the transactional process. You go to the dealership, the cars are gleaming in the spotlights, and somebody comes up to you and says, hey, sit down, have a cup of coffee. Tell me what you're looking for today. He engages you in conversation, not because he's friendly, probably also not because he's looking at the bottom line. He's been trained to do so. He's been trained with a very, very specific set of psychological vocabulary to talk to you to find out what your needs are. Oh, it's a leasing vehicle. Well, get the metallic paint. It's better for the resale value of the vehicle, things along those lines. And existing configurators as interactional tools are pretty tough to use. I just found out about something called a buildability conflict. Oh, you want to get leather seats? Well, that means that you have to have the heated seats, but you can't have this other option because we have a buildability conflict. Within the context of an automotive configurator, that gets to be pretty challenging. So the dealership goes a long way to make the experience much more engaging. You get a better car for your money. How did we start? We started with the human side of the project. We went to the dealerships, and we talked to them, we shadowed. We sat there like a shadow on the wall watching conversations between potential customers and dealers. We noted the vocabulary. We researched. We went to the schools. We found out what makes the dialogue so engaging, and then we copied it. We found out what the tonality was. And we took that. You've all heard about prompt engineering. I'm going to say something which is a little bit controversial today. Prompt engineering is obsolete. We are moving towards something called prompt compiling now, which is a new area of technology, and it is the future. It will enable conversations to become more and more and more human-like. We use emotion AI to find out, what is the person feeling? Are they hesitant? Are they happy? Are they irritated? I'll give you an example in just a few minutes, and we do that to ask condensed questions. So if somebody says, what are the advantages of a panoramic roof on my car? We don't have to have them write panoramic roof every time he has a question. We know what they're talking about. So how does that work? Well, as a human being, I have stable properties about me. When you're talking to me, you know I like pizza. I like pizza every day, and I probably always will like pizza. So we find out what that stable property of the person is. Person in a car configurator says, I want the M35 xDrive. He's talking in a pretty technical manner. We can respond to that information. It's a stable property about this person. It says, I know a lot about cars. So the 2 bits of information there, we know what they want to talk about, and we know what level of expertise they're bringing into the conversation. When we compile the prompt, which goes back into the system, we tell the prompt, give this person a technical answer. Recipient design, talking the language of the user to make a more engaging experience. So then we can carry the conversation forward. Instead of asking them something like, well, would you like a leather interior? So no, we can ask them a technical question to carry the conversation forward. Another one is a fluctuating property, something which is only true about me today. Maybe I'm irritated, maybe I'm in a hurry, so show me the engine options right now. Okay, also, we know what the person wants to see. Intent recognition has worked out just fine. But the implicit communication is, I'm impatient. I want to get through this process quickly. So once again, prompt compiling. We go back into our prompt library. And we put together each bit of the input. We add a prompt in there that says, give a concise answer. And when we do that, we carry the conversation forwards again. So I'm going to jump over this one. We just talked about that. Condensed statements I talked about earlier. And you're Mr. I know automatically I answer Fitzpatrick. So I have collaborated with my conversational partner to answer the question on a very, very efficient basis because we both have a common human context. You want scampi with that? With what? With my sushi? No. I want it on my pizza because we're talking about a pizza. We're talking about nothing else. The context is there. Something quick today. Paolo has seen that I'm in a hurry. Okay, we've got something. Just take a pizza margarita. It's faster. Don't have to go through a lot of rigmarole to get that. What about the other side, though? And you've all been in a restaurant. You're looking at the menu and say, everything on the menu looks so delicious. Well, that's a statement. But what it really means is I can't decide. Waiter, help me find a pizza here. Normally, I get a quattro formaggi because that's the pizza I like, but that's what I said. I meant exactly the opposite. What I'm saying is, by golly, today I want something different. I'll have the usual common context. He knows I want my pizza formaggi today just like I get it every time. We can condense that right down. So, coming towards the end of the talk, we want to create richer, more engaging experiences. We want to make a personal connection to the person. Not just with personalization in a shop, we want to go hyper-personal with them to make a meaningful relationship to the users of our digital application. We want to use those insights to steer the conversation in a productive way, but we also never want to overreact to what the people have said. So just a little bit about my company. We're here in Frankfurt, and we are at the cutting edge of using generative AI technologies to enable people to offer more engaging experiences to their customers. Obviously, any good presentation always has its literature and references. Do you have any questions for me? I thank you very, very much for listening. I had a great time talking to you.
Thank you very much. Questions? So I have a question. So you said your prompt engineering is obsolete, and you're doing prompt compiling.
Yes.
Can you explain this a little bit? Why the word compiling? Does it have to do with computer compilers?
It does. We're actually still looking for a better term, but everybody's talking about prompt engineering, meaning that they manually adapt the prompts to deliver a better result. We have taken our general prompt. We have a personality prompt, which is static and it never changes. We have a fluctuating personality prompt. And then we have different areas and different slots in the prompt so that we can literally control the situation of every turn that goes back in. But we go one step further than that, and we put everything into literally a database library. So the prompts are language agnostic. We can switch back and forth between languages by using just tokens. And also, we use the algorithms behind the Gen AI to algorithmically pull the components of the prompt from the library, put them together, and then send them to the system. That's one of the aspects of that. But we also use it, for instance, like I said, for condensed questioning and short-term memory. So take the context and feed it back into the system, but only after having analyzed the context using Emotion AI, for instance. So there are many, many data sources which go into the prompt. We have a set of building blocks in the library, and we compile them to put them back into the large language model. Good question.
Thank you.
Okay. Anybody else?
Hi. One question I have is, what pain points do you see, or what future challenges you see in implementing Motion AI, for instance?
That's a good question. Well, for instance, the last time I was here, we did a talk about Emotion AI, and let's say a typical Frankfurt statement. Frankfurt Eintracht lost the championship because the coach is an idiot. It's a statement. I can use that in an Emotion AI context. That's a negative statement, isn't it? But what if I'm a fan of FC Bayern? Then it's not a negative statement. It's a positive statement. So Emotion AI needs more than just context-based input. Biometric feedback would be helpful there too. Thanks.
Thank you.
You're welcome. Good. I have one last little statement just to give everybody something to think about. Last year when I did the talk here, a young lady came up to me to introduce herself afterwards and said, hey, hi, I thought it was interesting and all that stuff. And like I said, I have a startup here in Frankfurt we're up to 11 employees now, and she was the first employee of the new company. Yeah.
Nice. Okay, so let's thank our speaker once again. So now we are closing slowly. Do we have information about the next meetup? We have the announcement part. So we are a community AI meetup, and the members of the community are welcome to come here to the stage to make announcements. Like Dan just started making announcements. Right? So please, if you have anything to announce, please come here.
How many minutes do I have? I need to explain and then I'm looking for. Okay. Thank you so much, AI in Frankfurt, for the time. My name is Soraya. I come from Indonesia. So this is my first time speaking here. So thank you so much. We are from ICU, short ICU Technologies GmbH. So we are 1 year old. We are focusing on AI and data applications in the industry of pharmaceutical and life science industry. Why we're here? Because we would like to release the potential of the individuals in the industry and also free up our professionals in the industry to do more things that are more strategic. So this is why we create customized data applications for them. And our technical expertise, including modern data stack, machine learning operations or ML ops, as well as application integration. So we're always looking for people and team members. If you would like to join us, also to discuss with us, and if you feel resonated with these topics of life science, pharma, and building applications for the industry, and excited about it, please join us at the corner together with my founder Siegfried Eckstedt there. And yeah, there. And we're looking forward to be connecting with you guys. Thank you so much.
Hey everyone, my name is Madhuvanti, and I'm working currently on a startup which is based upon helping people to decide fashion, styling their clothes based on artificial intelligence. And currently we are looking for a chief technical officer who has experience in app development and also a minimum 4 years of experience. And if anyone is interested, I would love to talk with you more. Thank you. Anyone else would like to talk or announce? Food.
All right, nobody else. So the last piece of information, our next meetup event will be on February 22nd. We will send more information once we have it. We don't know yet the location, I think. So thank you very much for everybody for coming. I hope you learned a lot. I certainly did learn a lot from the wonderful speakers. And there's still 3 sandwiches left, so maybe, I don't know if it's useful information or not, because people are already in line. So, see you. Thank you.